So we have a number of people away today for a variety of activities, and a couple of them have asked if they could get a recording of today. So if you're watching this online, it's just a recording of, I'm not going to bother editing it, just a recording of the goings on in class today as we go through any questions that students have. To begin with, I suppose I should just mention basic structure for your exam. You know what to expect. Probably 15 to 20-ish numerical response, multiple choice types of questions. You know the same breakdown is always the case. Approximately 2/3 of the questions in that part of the exam would be multiple choice, and approximately 1/3 would be numerical response. And regardless of the numbers of questions there are in this part of the exam, we're talking about a weighting of 75%. And then one written response question with, of course, two parts, A and B. And this is always worth 25% of the exam. These are always marked out of a total of 5 marks. So there's a 3-mark part and a 2-mark part. Maybe the first part I ask you is the 2-mark, maybe it's the 3-mark. That's not important. Given that the written response contains one largish question and it's worth 1/4 of the exam, tells you again, and we've talked about this, that is not, some light fluffing of the unit. It's the meat of the unit. It has to be something which covers a number of different things. And I would say to you that as soon as you start to solve a rational equation, that would involve factoring, it would involve common denominators, it might involve using something from previous material, like using the quadratic formula and looking at 2 solutions you get out of the quadratic formula and throwing one over the boards and giving a reason why that one is excluded. And, I guess maybe I'm kind of telling you what to expect, but to me, I wouldn't just give you for 25% of the exam, here's an equation, solve it. I probably wouldn't give you an equation. I would probably give you a scenario where you have to come up with the equation to solve it. So now we're talking about your skills in solving equations, working with denominators, using maybe the quadratic formula, and interpreting a word description of something to develop a formula that you can use or an equation that you can use. But as I said yesterday, in terms of this unit, I know I could probably say the same thing about every other unit, namely that there's only basically 5 topics. Except that in every other unit, I think, when we have a topic, there's a lot of subtopics to it. Like if I said absolute value, well, there's absolute value functions, there's absolute value equations, there's piecewise, there's subdomains, there's a boatload of stuff just under that heading. But when I say simplify, and I'm not going to rewrite this again and again, we're talking about rational expressions. When I say simplify rational expressions, what else do you want me to say? Simplify rational expressions that have quadratics in them? Simplify rational expressions that are big? Simplify ones that are small? It's all about factoring and canceling. When I say multiply, this is another topic. Well, it turns out multiplying a rational expression is really simplifying a rational expression, right? When I say divide, well, it turns out dividing a rational expression, or rational expressions rather, is the same as multiplying because you end up multiplying by the reciprocal. There's a little detail in there about the non-permissible values that you're going to have to review. When I say add or subtract, I would basically describe this as two topics. Simplifying, multiplying, and dividing is all about the same thing. Factoring everything completely and canceling. The fact that when you're dividing, you have to multiply by a reciprocal first is just the detail you have to handle. And adding and subtracting, I would put in its own category as a topic. So I don't think, if you want to study for this exam, and you want to study adding and subtracting, it's not studying for a biology exam where you look at your cell diagrams or your diagrams of the systems, or you read the definitions of different types of active, passive transport, or whatever. I don't know bio, so I may be totally out to lunch here. But bio, there's a lot of memorization. Social studies, there tends to be a lot of memorization. Math, you can't open your books and study how to add or subtract rational expressions. You have to do it. You may need to write down on a little index card what that involves, find a common denominator, convert to a common denominator, simplify. But these are skills. This unit is mainly about skills. And you develop better skills by practicing. In addition to that, we're talking about rational equations. And really, I would say to you, there are two topics under that. How to solve a rational equation. And make sure that you know the difference here. I will describe it verbally, just briefly. Make sure that you know the difference between solving a rational equation and adding or subtracting rational expressions. They both involve common denominators. But when you're solving an equation, you use that common denominator to eliminate the denominators. You multiply everything by the common denominator, left and right side. When you're adding or subtracting, you convert everything to that common denominator. Now, just before I go on, I've said this already, and I said it already basically today, but I'm going to say it again. I hope you understand that multiplying is the same as simplifying. Yes? And I hope you understand that dividing is the same as simplifying. Because it's the same as multiplication, because you multiply by the reciprocal, and then you end up with a single rational expression. I'm going to go one further and say adding and subtracting in a particular way, not happy with that, in a particular way, adding and subtracting is also the same as simplifying. Because when you add or subtract rational expressions, at some point, you go from this to this. You don't start off here. You find a common denominator, you do a bunch of work to create two rational expressions with common denominators, but then you put it together as one, so now you're back at the beginning. Under rational equations, the other topic I would describe to you is word problems. And this is perhaps for many of you the most challenging part of the unit. It's not getting the answer once you've developed the equation, but it's getting the equation to solve it. Do you get my drift here? Of all those word problems, whether it's shared tasks like painters, speed, distance, time problems, traveling upstream and downstream, a shared cost for a field trip among students, a connection between integers that's in words, that's given to you in words. Those are all things that once you turn it into an equation, then you're solving it. And I really think if you approach this unit and most math in high school this way, you're more successful. You turn stuff into stuff you knew how to do already. You don't try to figure out how to do 100 things. You try to figure out how to turn 100 into 99, and those 99 into 98. And then sooner or later you have 5 or 6 things you need to know how to do in the whole course, really. That's the best I can do for you in terms of just a quick discussion of the exam and the unit. Let's take a look at your unit review handouts that I gave you. I have both up here. I have the one that has multiple choice and numerical response questions in it. I also have the textbook publishers extra practice that some of you picked up. So, fire away. I'm at your disposal. Go ahead, Claire.
Question 1 of the Unit 6 review, the first one.
Okay. So we're talking about this. From now on, I'm going to call it the main handout. This one? Okay, so 1, which of the following does not have any non-permissible values? A non-permissible value happens with rational expressions because you end up dividing by 0, right? So when we take a look at A, at 7x squared over x, x is not allowed to be 0 because if it is, this denominator will be 0. And it doesn't matter that that x in the denominator cancels everybody with an x in the numerator. We learned very early on, probably in the first lesson, that this expression, yes, does become 7x. And I'm going to show this to you again. But you have to say x is not equal to 0. And I want to show this graphically to you again, and then I will answer your question, okay? So if I were to look at y, oh, I don't like that mode. Let me get out of here. If I were to look at graphing y is equal to 7x squared divided by x, and don't worry about my window settings here. Don't worry about why I'm doing what I'm doing. What I get is a line, okay? And I've adjusted my window settings horizontally and vertically differently, so it's not a line with a slope of 1, okay? Turns out it's a slope of 7. And I am going to do something that you rarely ever do. I'm going to go to Format and turn my axes off. So here's the graph that represents the original function. Do you see there's a hole in the middle of it? Well, that's because if I go trace, well, I'll go to my table. If I go to my table and I look at all these values of x being not 0, I get y coordinates, and not 0 on the other side, I get y coordinates. X can't be 0, right? But if I were to graph this, it would just be a line without a hole. So I need to carry, this is the lesson, I need to carry those non-permissible values all the way to the end. I need to say they're always there. Okay. Is there a value of x that makes this 0? Yes. Is there a value of x that makes this 0? Yes. Are there values of x that make that 0? Plus or minus 1. Because what we're really doing is saying, for C, when I factor that, it factors as the difference of squares. I can picture a number for x in 1 plus x that makes it 0, negative 1. I can picture a number here that makes it 0, 1. But this, if I say to you x squared plus 9 is not allowed to be 0, solve that for me. Give me a number for x that makes it 0. You can't. Because if I try to rearrange it, I get that. Let's forget about the not equal to for a second. If I just said to you, what value of x makes this 0, you would come to the conclusion that x squared has to be negative 9. Well, it can't be. You can't square something and get a negative. The only way, Claire, this denominator can be 0 is if this has a value of -9. Right? That's the only way it would reduce to 0, but you can't square something and get a negative number. I guess maybe what I'm saying is if the denominator set equal to 0 has solutions, those solutions are non-permissible values. Is that okay? Okay. Other questions? Go ahead, Owen.
7, numerical response.
Numerical response 7. Oh, this is a tricky question, I think. Boy, this is a really tricky question, okay? But I like the question a lot. It is something that is very close to what we might encounter in Math 30. In fact, we did a question very similar to this in terms of how it's solved in Math 30 yesterday. You are going to run into trouble if you say to yourself, well, -2x minus 4 over x times x minus 1 needs to be turned into this. And if you approach it by saying, well, what can I do to this expression on the left to turn it into that other expression, I don't think you're going to be successful. But what we can do is the following. We can go the other way. And at first you're going to wonder, well, what good will this do? Let's put these two together with a common denominator. I'm going to have to multiply the top and the bottom of this expression by x minus 1 to get my common denominator. And I'm going to have to multiply the top and the bottom of this expression by x to get my common denominator. So I'm going to get a times x minus 1 minus b times x, and this will be over my common denominator. Now, I don't want to write equals here. I just want to put beside it -2x minus 4 over x times x minus 1. Okay? We're told in one way or another these two expressions are the same. But my denominators are the same now. And that means my numerators have to be the same. So let's keep that in mind, and I'm going to simplify this. ax minus a minus bx over x times x minus 1. And I'm going to rearrange the top of this just ever so slightly. And as we get closer to Math 30 and into Math 30 and deeper into Math 30, you're going to learn more and more that the questions we ask on exams are not necessarily simplify this rational expression. It's not that we're going to learn how to do something and then you're going to be asked on an exam 5 times to do that thing. You have to be able to take what you learn and adapt it. So here's where we're at. And this is equal to -2x minus 4 over x times x minus 1. Now I have a question for you. How many of you see that a has to be 4? See, the reason is these two terms that I'm going to highlight, these have x in them. They're going to have to combine together to give the -2x. So we're going to solve this problem from this point on, not by looking at a system of equations or anything. We're going to use common sense that since this is -4 for a constant and this is minus a must be 4. Now, what about b? Well, I guess we can put 4 in here for a and get 4x minus bx minus 4 over x times x minus 1. But this has to give us negative 2x. So what will we take away from 4x to get negative 2x? We would have to subtract 6x. And that means that b is 6. Now there is a more formal way to solve this, but I really like this approach of comparing the constant term here to the constant term there, and then just getting an answer. Is there another way to do it? There's something creeping around in the back of my head that says yes, but I don't want to commit to it until I'm sure, so I'm not going to do that other way, because it might just go nowhere and waste everybody's time. So a little bit later I'll finish my thought and see what happens. Other questions? Abby? Numerical response 9. So anyway, A is 4 and B is 6. Right? We were just talking in my Math 30 class this morning about how, you know, it has to do with a totally different set of concepts, but we learned something today where they learn how to do a particular problem and it seems so simple when they do it, but then I give them a whole list of 8 or 10 problems and 5 of them they don't know how to do, but it turns out those 5 are exactly identical to the first problem. They're just worded differently. So this is the classic speed, distance, time problem. It's disguised in many different ways. So we have the speed, the distance, and the time. And we have 2 trips. Sometimes it's Paul driving someplace and Alva driving someplace else. Sometimes it's a train going fast and the same train later going slow. Sometimes it's traveling upstream. Sometimes it's traveling downstream. Sometimes it's flying in a jet and driving in a car. And I won't say that this is always going to be the case, but by far, most of the time, you're going to be given the distances and asked about the speeds. And in fact, even if you were given the distances and asked about the times, I would still find the speed first to find the time. Okay? And that might pop up in one of these review questions. Anyway, Abby, do you see this is 2,520 kilometers? And this is 420 kilometers. And I think although there are 2 ways you could fill in the speeds, I think this is the most reasonable approach. And you might wonder what the other way is, and I don't know why anybody would do this. But you could. I don't know. Yeah, I'm with you with the look on your face. I don't know why anybody would decide to go that way. It would work. So then the next step is to always, so you fill in the distance with the numbers. You fill in the speed column with a variable that will give you the answer to the question. Now, look at this. Actually, this is the question I was thinking of. It asks about the time. So it would be a mistake for you to put, I think it would be a mistake for you to put x here and x plus 1 here and write an expression for the speed. I think that's a mistake. And I'm glad that the look on your face and some other people's faces is telling me that you think that would be a wrong direction as well. Even though we're not asked for the speed, let's find the speed and go from there. Okay. I think, Abby, you're fine with this idea that time is distance over speed. So this will be 2520 over 8x. I'm really hopeful that 8 divides into 2520. And we always want to look at that. Don't get carried away and build a big equation and solve it, because it could simplify. 350. So this is going to be 350 over x. 315? 315 over x. But we'll take care of that in a second. And this is going to be 420 over x. And now, it's interesting, because if I give you these tools, make the chart, fill in distance, fill in speed, fill in time, that's not the issue. And when you get the equation, usually for most people, so this is usually not the issue for most people. And when you get the equation, solving the equation is usually not the issue. The issue is, what do you do with these two things to get an equation? And it seems as though it shouldn't be difficult, but let me just throw something your way. Clearly the difference between these two times is an hour, because it says it takes an hour longer. And the first time I taught this, first, second, I'm going to leave it as this so I don't confuse people. We'll whittle it down later. The first time I taught this, I realized very quickly that one of these is right and one of these is wrong. Right? They can't both be right. But I realized very quickly that it's not a simple thing to think out. It really isn't. And I'm saying that for me personally. It's not something that I just read the question and go, oh yeah, it's this one. So let me run through different lines of reasoning. Okay? If you want to think purely mathematical, let's rewrite this as 315 over x. I'm going to write my two options again. Now this first method of deciding which it is only going to work because they both have x in the denominator. Okay? And it's kind of what Owen had thought of the other day, where we looked at the size of the denominator and talked about the whole fraction. When I take a look at what I'm going to call 1 and what I'm going to call 2, which is bigger? So, from a purely mathematical standpoint, not reading the question, 420 over x is bigger than 315 over x, because the numerator is bigger. So 420 over x, if you're watching this on video, I'm holding my hands out like I'm holding the same weight on each hand. But my right hand, which is on your left, represents the 315 over x, which is less. Which means this is tipped this way to the side where there's 420 over x. What I'm saying is, just in case you're watching on video, that if I had a balance scale, it would look like this. Because 420 over x is bigger. So how do I correct that? How do I balance this? The answer is, I add 1 to here, and it balances out. Well, and it balances out. I'm spatially challenged this afternoon. It balances out when I add 1 to the smaller side, which means, everyone, this is correct. Okay. That's one way you could do it. Now, the only reason that worked was because they were both over x, so we could compare them that way. So instead, we can look over here and say, again, I'm going to go 1 and 2. Which is bigger? Well, we already know this is bigger, right? We figured that out. But let's find out which is bigger by looking at the question. This is the time for the jet, and this is the time for the car. And I really believe spending an extra 10 minutes of today's class talking about this is important. Because if you have a multiple choice question like this, and maybe you have a written response question like this, you need to know which one to go with. So now we have to read the question. And even this is tricky. It says the time driving is 1 hour longer. Okay, so I know that not all of us have great reading comprehension. That's not a criticism. We just all are at different levels. But when I read driving the car is longer, I say the time in the car is bigger. Right? The time in the car is longer. Man, have you ever been on a long car trip? The time is long. It's big. It's a large numerical value. And that means that this is bigger. It's a longer time. So I'm still taking this balance approach that the 420 over x is heavier, mathematically speaking, than the 4520 over 8x, so I have to add the 1 to the other side. And by the way, it was an hour, and this is kilometers and kilometers per hour, so we're okay. You could also do this, finally, everybody, not by looking at a comparison, but by looking, and we did this morning in Sabre Support, and it's not always ideal, by looking at the sentence describing things. The time driving is 1 hour longer than the flight. So the time driving is means equals. 1 more than means you add 1 to. The time for the flight. And we still end up adding 1 to the time for the flight. The only issue is sometimes the language, it doesn't say is, right? We saw a couple this morning where you really had to think carefully about the language. And it wasn't tricky language. It's just that it was different language. Anyway, let's finish this problem now. This is the equation we are dealing with. And I do want to finish this because even though I think solving this equation is standard, x is not the answer to the question. Okay? So the first thing we're going to do is, again, recognize that we can simplify this. I think you said 315 over x. This is a huge get for us, meaning it's a big deal, because now I can just multiply everything by x and not 8x. And if I did 8x, the numbers would be bigger than they need to be. I'd still get there. So I'm going to multiply this term by x, this term by x, this term by x. It's going to become really simple, actually, to solve this, because I am going to get I am going to get 420 equals 315 plus x. Now, how often does that happen, where you have a word problem that turns into not even a linear equation, but something where you can just subtract to get x? I believe when I subtract this, I get 105, but it has been an awfully long day. And okay, so that's good. My brain is still clear a little bit. So what does that mean? To answer the question, we have to go back up here and say that this is 100, and did I just say 115? 105. See? Long day. This is 105. What, and that would make this, in case we need to know it, 840 kilometers per hour. It says how many hours are spent in the car. So you can either use speed equals distance over time with that value of x, or, you know what we could have done? You could have just put 105 in here. And if it said how many hours is spent in the plane, you'd put 105 here. So 420 divided by 105, it happens to be 4, I think. Is that okay? Okay. Other questions? Okay, just give me a second here. What do I want to do? I'll move this over here. So I'm going to do numerical response number 12. I would say, because there are a number of ways to do this kind of shared cost problem, that I don't think it's worthy of a written response, but I definitely think it's worthy of a numerical response. There's no way I would give you this as a multiple choice, because then you could just try all your choices and see if they work, okay? And the reason why that strategy would work is because the answer has to be a whole number, right? So we have a group of students that are going to share a trip, financially share a trip of $8,500 for a cost. And due to a variety of reasons, 6 students decide not to go. And as a result, the average cost per, that should say student, increases by a certain value. So when you find an average amount of something per student, you take the total and divide by the number of students. But, and this is the thing we talked about the other day, what do you want to let X be? Do you want to let X be the number of students who were going to go on the trip, or the number of students who do go on the trip? And it's up to you. We're going to go. And that, to me, that makes more sense. Regardless of what the question is asking you to do, I would always say that N, did you say who we're going to go? Okay. N is the number who were going. And that means that they were going to pay each, to begin with, they were going to pay whatever 8,500 divided by N is. This is the cost per student if everybody went. Right? But 6 decide not to go. So what is the cost per student if fewer go? Well, it will be 8,500 divided by how many end up going, which is 6 less. And I may have started this off, Melanie, by saying X. Somewhere along the way I used N for number of students. That's okay though, right? So these two amounts, the cost per student if they all go, and the cost per student if 6 decide not to go, these are different amounts. And you're told the difference is $37.50. So we have that same dilemma we had before. I either have to take this 8,500 and add 37 over N and add 37.50 and set it equal to this other one, or subtract it, or add it to the other one, or there's all kinds of scenarios. So I really like this approach of these two things are not equal, right? One of these two things mathematically is heavier, or for the students is more. Which of these two is a bigger amount? It's actually this one. Now we can arrive at that, so I'm going to put this here and I'm going to explain why it's 8,500 over N minus 6. I'll explain why. in a number of ways. One of the reasons is, imagine you're one of the people that's going on the trip. That means you are in this group here. Your cost goes up, so this cost is greater. We could say as well that since this denominator is smaller, the entire fraction becomes bigger. So I'm going to have to add the 3750 here. Now I do have to ask, is in your head, when you said this one, would you have put the 3750 with it? No, okay, so I just wanted to check. The other option is, so now these will be equal, and I'm not going to try to twist that so it's balanced. The other option is to, simply say that the cost per student when fewer go is increased by 3750. However, all this being said, and everybody, I'm giving you a good advice here, I don't think you need to solve this problem this way. Okay? What you can do, since it is a numerical response question, which means nobody really cares how you get the answer, is I can put into my calculator for y1, I can put 8,500 divided by x, and 8,500 divided by x minus 6. And we might even be able to get away with here, everybody, not knowing which is bigger. We might. All we want to know is one is 3750 more than the other. So what we'll be doing is going to our table setup. I'm going to start at 0 and go up by 1, and then I'm immediately going to say, well, wait a minute, this is a group of students. It's probably not 1 or 2 or 3 or 4 students. Why don't we start at 20 students or 25 students? We can always scroll in the opposite direction. I'm going to start at 20, and I'm going to go to my table, and I'm looking here. It requires a bit of thought, but I'm looking here for numbers that are $37.50 apart. And when I look at these two numbers at 20, they are over $200 apart, almost $200 apart. And when I look here, they're closer together, aren't they? I'm looking for something that is $37.50 apart. Like, well, they're almost equal. No, they're not. We're getting really close. Are they getting further apart now? They are getting further apart. See, I would be tempted here to do the following. What's up? Tell me. I could use a laugh. What? Or you don't want it? You shouldn't tell me?
No, someone's not. It's just an going on.
Oh, okay. You know what I'd be tempted to do here, everybody, is I would be tempted to put in here the following. 8,500 over x minus 6 minus 8,500 over x. And then in my table, I'm simply going to be looking for 3750. Now, how many of you understand that I subtracted these in the order they should be subtracted in? Okay. So the risk here is if you don't know the order they should be subtracted in, we might find in the table not 3750, but negative 3750. Right there, 40 students. which is what you would get if you solve this equation. But if you solve this equation, oh man, this is going to be, well, it's not going to be that bad. Yeah, it will, because this is just over n, isn't it? Yeah. So this is going to turn into quadratic, whereas if you solve it with your tables, you get an answer very quickly. The other problem here, though, everybody, is, and a lot of people will get this wrong on the exam, 40 is not the answer. 40 is how many students were originally planning on going on the trip, because that's what you decided to use, and that's what I would decide to use. So then what you have to do is you have to say, I'm going to take 6 off of that and get 34. No?
It's 36. Oh, sorry, yes, it's 34, 34. It's 34.
Is that what I said?
Yeah, it's 34, yeah.
Numerical response 3. The first thing to note here is that this whole x is not equal to -7/2 or 0 or 1 is just fluff on the question. It's just telling us there are non-permissible values. We're told that this product of these rational expressions on the left is equal to 3x plus k. So in my mind, we're just going to simplify that product and see what we get. And you simplify this mess by factoring completely. So in the numerator, I can factor 3x squared out and be left with 2x plus 7. In the denominator, I can factor an x out and be left with x minus 1. The numerator of the second expression factors into x minus 10, x plus 10, x minus 1. The denominator, I can take an x out and be left with 2x plus 7. So now, look at all the canceling. I have x squared on the top, and I have x times x on the bottom, so those are gone. I have 2x plus 7 on the top and the bottom. I have x minus 1 on the bottom and the top. The only thing I have left is 3 times x plus 10, which gives me 3x plus 30, so k is 30. Good.